the start state. So that's like your A and that's your S, so to speak. So it's the epsilon, so you don't care about the input stream, you're not doing anything with it, just ignore it. Similarly here, you don't care, you're not looking, you ignore what's at the top of the stack, right? You don't care. And this gives you a set of ordered pairs, sort of like the instructions. So this would be like your R here, right? Now, in other words, the next state. So go into loop. So once you've pushed the dollar, and I'll explain that in a minute, then you're ready to go into this loop, this substitution loop, overwriting loop, where you substitute a variable for the right hand, the string that's on the right hand of a substitution rule, where the left hand of that rule matches, agrees, is the same as the variable that's at the top of the stack. Okay, now so here's your string now that you're asked to push. So you will push S dollar. Now can you see, now be careful, note the order. Now S is, what is S? That's your start variable, start variable. S is your start variable. Okay. Now note the order, because you'll push S first. Wait a minute. No, sorry. You'll push the dollar first. So you put the dollar on the right hand side, because here, remember, look here. When your string is X, Y, Z, we push Z first. We push the rightmost symbol first. Okay. So here we have two symbols, and so we want the dollar to be pushed first, right? That's initializing the stack. You put the dollar on. That's the first thing you put on your stack, is the dollar sign. That's your indicator. When you see the dollar again, that means you know the stack is empty. All the things that were on the stack have been popped, just leaving the dollar. So you know your stack's empty. That's the whole point of using the dollar. Okay. So note the order. All right. So what's this doing? It's pushing the dollar to initialize the stack, and then putting the start variable from the grammar. Okay? The start variable. This is your start variable from your grammar. So now your stack will have the start variable S, and underneath it on the stack will be the dollar, and that's what that does. Okay. And then you transition to the next state, which is loop. Now you're in this state, and you're going to loop for a while until eventually you will get, hopefully, one of your branches, because it's non-deterministic, right? So hopefully one of your branches will succeed. Now what does that mean? What does it mean to succeed? It will mean that the PDA has accepted the same string as the grammar has generated. Now, that means your PDA. Now PDA, it's essentially two things, right? It's the input string and the stack. So the string that you're inputting to the PDA, that's a string that your PDA has to accept or reject, right? So if you're if your PDA is behaving like a grammar, in other words, using successively substitution rules or rewrite rules, then if that PDA ends up, when the last symbol in the input string has been read, if that machine, that PDA, ends up in the accept state, that means it has accepted that string. Okay. So if it can end up in the accept state, reading this string by behaving like a grammar, then by using the stack to hold the intermediate strings being generated by the rules of a grammar, then it's effectively behaving like a grammar in generating a string, but it's a PDA, so it's reading the string. Now, if it gets to the accept state by a series of substitution, application of substitution rules, then it's behaving equivalently to just accepting the input string and generating it by acting as a grammar. Okay, so in other words, your PDA is behaving just like a grammar. So it's in a sense simultaneously accepting the string as a machine, as a PDA, but also generating that that string by substitution rules. Now remember, well, we'll get into the detail. You'll see how it's done, and then you'll see in what sense the two are equivalent. As usual, the devil is in the details. Right. Okay. Okay. So we're now in step 2 of the idea, the proof idea we talked about earlier. Right. Now there are 3 cases. Case A is where the top of the stack is a variable. Case B is where the top of the stack is a terminal. And case C is when the top of the stack is your dollar sign. In other words, the stack is empty. Right? So let's do the 3 cases and find for each case the corresponding. There will be for each case a corresponding transition rule, a delta. Okay, right? So we're looking now at the top of the stack, and if it's a variable, then we will pop that variable, and we will then push the right hand side of the transition rule that corresponds to that variable. Now if we have several of them, if there's several transition rules that have the same variable on the left hand side of the rule, well then we split. It's a non-deterministic PDA, right? So we make copies of the machine, and we put the right hand side of the transition rule on the stack. We push it for each copy. One rule, one copy of the machine for each rule whose left hand side is equal to the variable on top of the stack. Okay, so here's your transition rule, and see if you can figure out how it is. Now we won't change the state. We just stay in this loop. We'll only change the state when we get the dollar sign. When everything, and if we get the dollar sign, that's a sign of success. As you'll see in a minute. But okay, so we'll stay in the same state. Here we don't care what's being read on the input string. The eta don't care. Now this is you're looking at the symbol on top of the stack, and it's A, capital A. That's a variable, right? Convention is variables are in capital letters and terminals are in small letters. This is a capital letter, so it's a variable. Okay? So what we want to do now is we want to pop the stack, get rid of that variable at the top of the stack, go looking in the set of rules, your big R, in other words, for your grammar, find one or more substitution rules that match, where the left-hand side of the rule is equal to this. Have a look, take the right-hand side of that rule and push it onto the stack. Well, let's say this is one of the rules in your set of rules, big R. Say that's the rule. Okay. Now that A here, left-hand side, matches what's at the top of the stack. Okay. Take the right-hand side of the rule and push it onto the stack. So in other words, you're using the stack to store the, intermediate string that is being generated by the grammar, but you're using a PDA to do it, right? So the stack contains the current intermediate string that's being expanded using substitution rules. Okay? So the stack, well, PDA, is behaving